Welcome to The Explainer, where we break down big ideas from the source.
Ever wondered how that works? Well, a lot of the time, it comes down to an AI tech called point tracking. And believe it or not, there's been a really fascinating breakthrough in how we teach AI to do this.
All right, so let's dive right in. To really get what's going on, we first have to understand the core task and, the massive challenge that comes with it.
So, point tracking, you can think of it as the invisible engine behind so much of the visual tech we use every day. I'm talking 3D reconstruction, super complex video editing, all of it relies on this. But here's the thing, training an AI to be this precise, it's incredibly difficult, and it all boils down to one huge bottleneck, data. Right, and that whole data problem? It leads us straight to the central dilemma that researchers have been banging their heads against. See, to teach an AI anything, you need examples, lots of them. But getting the right kind of examples for this, well, that's turned out to be almost impossible.
Basically, you've got two main options, and honestly, neither of them is perfect. On one side, you have synthetic data, computer-generated videos. Super easy to label automatically, which is great. But there's this big sim-to-real gap. The AI learns in a cartoon world and then struggles when it sees the real thing. Then on the other side, you've got real-world videos from the internet. Perfect, right? Well, not so fast. Imagine trying to manually label millions of points, frame by frame. It's a total non-starter. It's a classic catch-22.
So, the previous champ, the state-of-the-art model, was this thing called Pseudo-Labelling. And its creators looked at this dilemma and decided to solve it with just sheer scale. They picked the real-world data path and just decided to go absolutely massive.
And when I say massive, I mean it. We're talking a staggering 15 million real videos. They threw all of this into a super complex training process. It was pretty much a brute force approach, just hoping that if they threw enough data at the problem, it would eventually figure it out.
Okay, so you have this brute force method. But now, the creators of a new model, COTRACKER3, came along and asked a really brilliant question. They said, wait a minute, what if we could get all the benefits of real-world data, but without needing millions and millions of videos? What if we could just work smarter, not bigger? And their solution? Yeah, it had nothing to do with brute force. Instead, they came up with this really clever, super efficient method they call semi-supervised training. The way they do it is it's really elegant. So instead of having one model learn all by itself, they get together a whole panel of existing models. Let's call them the teachers. They let these teachers watch a pretty small set of real videos and automatically create labels for them. We call these pseudo-labels. Then the new student model, which is COTRACKER3, comes in and learns from what the teachers did. And the result is kind of amazing. The student ends up absorbing the combined strengths of all its teachers and actually becomes better than any single one of them. So why does this work so well? Well, it boils down to a few key things. First, you get this wisdom of the crowd effect. The different teachers might make different mistakes, and those errors tend to cancel each other out. Second, the student model gets grounded in what real videos actually look and feel like, bridging that sim-to-real gap we talked about. And maybe most importantly, it inherits the best parts, the unique strengths from each individual teacher. The end result is just a much more well-rounded, robust model that's also incredibly data efficient. Okay, so it sounds like a really clever idea on paper, right? But the big question is, does it actually work? Does it outperform that brute force approach? Oh yeah, the results are pretty staggering.
Let's look at the numbers. On a key industry benchmark, the old champ, Boots Taper, got an accuracy score of 61.4. COTRACKER3, it scored 63.8. Now, that might not sound like a huge leap, but remember, it did this using a tiny fraction of the data. So it's not just a small improvement, it's a significantly better result with way fewer resources.
When you see it laid out like this, it's so clear. This is literally what smarter, not bigger looks like in practice. It's a definitive win on performance, and it was done with just a sliver of the data the other model needed.
And here it is, the real punchline. It got that better result using, get this, 1,000 times less data. I'm going to say that again, 1,000 times. That's not a typo. That's an insane level of efficiency, and it represents a massive leap in how we should be thinking about training these models.
But wait, there's more. The advantages here don't just stop with data efficiency. The researchers found that COTRACKER3 has a kind of superpower, something other models really struggle with, and that's handling objects that get hidden for view. So this superpower is dealing with occlusion. That's just a fancy word for when a point you're tracking disappears for a second. Like a person walking behind a pole. For most trackers, that's game over. They just lose the point. But COTRACKER3 is different.
It tracks points as a group. It uses this really cool technique called cross-track attention to understand how a whole collection of points move together. So if one little point disappears, it can use the motion of all the other points around it to make a really smart guess about where that hidden point is going to be. Then, boom, when it reappears, it picks it right back up like nothing happened.
Okay, let's zoom out for a minute and think about the big picture. What's the real takeaway here? Because trust me, this is about way more than just tracking dots in a video.
What COTRACKER3 proves is so important. Its success isn't just about making a better point tracker. It's a powerful proof of concept that signals a potential shift in the entire philosophy of how we build powerful AI.
You know, for years and years, the mantra in AI has been bigger is better. Just get more data, build bigger models, throw more computing power at it. That was the old way. COTRACKER3 shows us there's a new path. It proves that real progress can come from smarter, more efficient training methods, from elegant ideas that let us get more from less.
So this leaves us with a really fundamental question about the future of AI. Is it all about bigger data, or is it about smarter ideas? COTRACKER3 doesn't just ask that question, it gives us a pretty compelling answer. It suggests that the next great leaps forward might not come from building bigger and bigger digital brains, but from simply having smarter ideas in the first place.